area under here, this curve, and from A to B, okay? I'm going to calculate the area from here to here, okay?
Okay.
So you can cut from A to B into several different small intervals, and you can calculate those rectangular area and add up together. That's going to be the area under the curve between A and B, okay? That makes sense?
Yeah.
Okay. So if we say we split from A to B into n equal pieces, okay? And we say each this of the rectangle is delta x at k is from B minus A divided by n pieces, all right? So each rectangle area is going to be using the height, which is f of ck, okay, or fxk. This value is called ck or xk, doesn't matter. Then this height is going to be the f of ck, right?
Yes.
The height times the width, okay? This height times the width is going to be the area of each individual rectangular, okay? If you sum from the first one, this is the first one, this is the second one, and you sum all of this together, okay, until the last piece. This is going to give you an estimation of the area under the curve. Okay, this is called a Riemann sum. Yeah, but don't worry, this formula looks complicated, but I'm going to show you the real example. Okay.
Okay.
And if we want to get the exact area, you have to make this n into infinity, right?
Yes.
If you make this guy into infinity, then each small pieces is going to be really tiny. And then the height times the width is going to be the exactly solution if you sum it together by infinite pieces. That makes sense?
Yes.
Okay. So the definition of a definite integral is called from A to B. This is the integral sign, fx dx. This is a limit. You do n to infinity, and then you remember, you write down this sigma sign. This sigma is doing the summation. Remember when we do the sequence and series, you see? A1, A2, AN, okay? If you want to say Sn equals to A1 plus A2 plus all the way up to AN, then you can use this as sigma, okay? Sigma AN. You can do sigma AI. I is from 1 to n. So this sigma is a calculation to the summation, okay? And then you use the height of each function and then times the width of each rectangle, okay?
Okay.
That's how to remember. So we can hide here, we can see, let's rewrite this one by ourselves, okay? So if I want to say, how do I remember this one? We know that we want to do the summation, right? Yeah,
Yes.
we want to do the summation. And our summation is from the first one to the last one, which is the nth one. And then the height of each triangle is going to be, you see, you can see ck, or you can see the subsequent number is I, so you call it fxi. And then times the width, which is the delta xi, okay? That makes sense?
Yeah.
Yeah, or this one here, they use k. If they use k, we change to k, doesn't matter, okay? That makes sense now?
Yes.
Okay. If you do like just the 3 intervals, then it's just the estimation. If you make this n to infinity, then the area is going to be the exactly area, okay? That's what the definition of definite integral is. So let's go ahead and do some questions, okay? So I'm going to come to this one. The first question is y equals to square root x, and doing from 0 to 1, make a full subintervals. So I draw a y equals to x, square root x, as here. And from 0 to 1, this is 0, this is 1. N equals to 4 subintervals. 4 subinterval is saying you split from 0 to 1 into 4 equal pieces, right?
Yes.
So here is 1/2. 1/2 is 1/4. From here to here, 1/2 is 3/4, right?
Yes.
Okay. Left Riemann sum. What you are going to do is you are going to choose the point from your left. Okay, so you choose 4 points. You start from this guy over here. Okay, so you are going to start from your most left point, which is this point. And then you find out this point's height. This F0 is 0, right?
Yes.
Okay, so this is the most left point. And then you see here, you choose this point, this point, this point, and this point, right? 4 points. That makes sense?
Uh-huh.
This is called the left edge of each rectangle, okay? So the second point is 1/4. 1/4 equals how much? Square root of 1/4 is 1/2, right?
Yes.
Okay. And this next one is this guy, yes?
Uh-huh.
And then you do f of 1/2, which is square root 2/2, right?
Yeah.
Okay. Next one is 3/4. So 3/4, f 3/4 equals square root 3/2, right?
Yes.
Okay. Now we get the left edge of each rectangle, and we are going to use this height. We use this height times this width. This is 1/4 for each subinterval, right?
Yeah.
Each subinterval are the same, which is 1/4. So you use 0 plus 1/2. This 1/2 is the height over here. This is 1/2. And then square root 2/2 is this guy. And then square root 3/2 is this guy. So we use this value, y value, plus this y value, plus this y value, plus this y value, times the subinterval value, which is 1/4. So we get the area, look at here, okay? We get this area and this area. This area, and then this area. That makes sense?
Yeah.
So this is called the left sum. All right?
Oh, okay, I see.
Okay, you can write down some notes, okay?
Mhm.
Now you can do by yourself. Do the right sum. When you do the right Riemann sum, you're going to choose from the right point, okay? So you are not going to choose the left one. The left sum is 1, 0.1, 0.2, 0.3, 0.4. The right sum is 0.1, 0.2, 0.3, 0.4. Okay?
Okay.
Yeah, so you can go ahead do it. So your first point is not 0. Your first point is 1/4. Did you get it right, Riemann sum? So the first point is at 1/4. That's 1/2. Your second point is at 1/2. That's square root 2 over 2. Your next start point is 3 over 4. Then this is square root 3 over 2. The last point is at x equals to 1. So this guy go to 1. So the right Riemann sum is using this guy plus this guy plus this guy plus this guy and times the subinterval, which is 1/4.
I got 0.768.
Yeah, so that's your left, that's your right one. The next one is called the midpoint Riemann sum. Midpoint is you are taking the point, the midpoint between the left and the right, okay? So you are going to choose this guy, this guy, this guy, and this guy. That makes sense?
Yes.
Okay. And by doing the midpoint sum, and you are looking for, you get the midpoint first. Between 0 and 1/4, what's the midpoint?
1A.
Good job, 1 is. Between here and here, okay? Between 1/4 and 1/2, what's this midpoint? You do this. Yeah, that's the midpoint.
3. Yeah, 3 over 2.
3 over 8, right?
Oh, yes.
Okay. Now you do this midpoint, okay?
Over 8.
5 over 8, okay? Good. Now last one.
7
Okay.
over 2.
7 over 8. So you get this individual height. Yes?
Yeah.
Yeah. By plugging into the square root of x. So you got this, 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 this. Now, you based on this, you use this height and then times 1/4, which is a subinterval. That's going to be the area called midpoint Riemann sum. Does that make sense?
Yeah.
Okay. Now that's the first example. Second one, I'm going to ask you to do this, okay? So you want to use this one. Now, we want to draw this one. Okay, let's draw this one. Y equals to 1 over x. Okay, and then I'm going to zoom in to just 1 up to 3. Okay. All right. So I'm going to screen capture here. All right. Now I can load it. Now we can mark, okay? Now, from 1 to 3, so you first want to mark your left edge and the right edge, okay?
Okay.
1, 2, 3. This is 1. This is 3. Okay.
Mhm.
Now, based on this, we are going to do the left Riemann sum first, okay? Yeah.
Okay.
So we do full interval. We still do full intervals, right?
How do you know how many intervals?
Say one more time, please.
How do you know how many intervals to do?
They told you
Oh, okay.
here. So this guy is from 1 to 3. Full intervals. Full intervals, so that's going to be just like this, okay? So the
Mhm.
left Riemann sum, we can say it starts from the left. Yes,
Yes.
all right. So the left Riemann sum, we can do F1, all right?
Okay.
F1 is how much?
1.
1. And then F3/2, right? Yeah.
Oh,
This
my God,
guy is
yes.
3/2. Yeah, it's better to use fraction. And then F2. Yes.
Mhm.
And next one is between 2 and 3. So that's going to be 2.5, which is 5/2, right?
Yes.
All right. Now we want to do the Riemann sum from the left. And the subinterval is 2/4, right?
Mhm.
Which is 1/2, correct? Yeah.
Yes.
The previous one is 1/4 is because it's from 0 to 1. From 0 to 1, 1/4 is 1/4, but this guy is from 1 to 3, so the subinterval is 1/2. So the left Riemann sum is going to equals to 1 plus 2/3 plus 1/2 plus 2/5 times 1/2. All right.
Okay.
Okay, this is the left Riemann sum. Now let's do the right Riemann sum. So the last point is at 3. Okay.
Okay.
Yeah, you do a very good job for taking care of the test by reviewing it. Then you feel much better, right?
Yeah.
So we want to move this guy to the front. And then we can plus the 1/3 for the last term, okay?
Okay.
Does that make sense?
Yes.
Now we can do the midpoint, okay?
Yeah. Okay.
So for the midpoint, we are going to first get the point, okay? The midpoint is here, 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 and here, right?
Yes.
Yeah. So we want to get from midpoint of 1, and this is 3/2. This is 5/2. So if we want to get the midpoint here, yeah, I'm going to write down over here so that I will not confuse, okay?
Okay.
Yeah. So the midpoint between 1 and 3/2 is going to be this. That equals to 1/2 times 5/2, which is 5/4. Correct?
Yes.
Okay, yeah, in this way, we won't get it wrong. And the next one, we are going to do 1/2. And between this guy is 3/2 plus 2, right?
Yeah.
Okay, so this becomes to 1/2, and then 7/2, right?
Yes.
So that's 7/4. Okay.
Mhm.
And the last one, actually, you notice that each one is still by plussing a 1/2, right? Yes?
Yeah. Yes.
Because 1/2 is a interval. So last one has to be 3/4 plus 1/2. We can also do this quickly. Okay.
Okay.
So this is 4, 7 plus 2. That's 9/4. Yes.
Yes.
So the midpoint, hold on. We want to calculate the F value. F 5/4 equals to 4/5. F 7/4 equals to 4/7. F 9/4 equals to 4/9. And there's another one. So this is the third point. And the last point is going to be 9/4 plus 1/2, which is 4. 9 plus 2, 11, right?
Yes.
So F 11/4 equals to 11, 4/11. Okay. Now we can do the midpoint. All right. So let's use the calculator to estimate the value here. Okay.
Okay.
Yeah, let's calculate this guy equals how much. So if we do 1 plus 2/3 plus 1/2 plus 2/5. All right. And then times 1/2. So this gives us a value about 1.283. Okay.
Okay.
Now we want to change, we can, everything else is same for the right subinterval, but just the first one. So I'm going to switch the first one to be 1/3, right?
Yes.
Okay, so this guy gives a value about 0.95. Yes?
Uh-huh.
Okay, the reason I teach you this one is to prepare you ready for the overestimation and underestimation, which is a hard topic later on. Okay,
Okay.
so let's do this kind of calculation. 4/5 plus 4 over 7 plus 4 over 9 plus 4 over 11. Okay, this gives me a value about 1.0809. Okay, yeah. So we see these three values. We do notice that. Okay, let me see if I can move this about. Okay, we do see that the left Riemann sum is the biggest one. The right Riemann sum is the smallest one. Okay.
Okay.
This right one is smaller than midpoint, smaller than left sum. Right?
Yes.
There is a reason. There's a reason for this. And before we do that, and I also want to talk about the real area. So if you do the left Riemann sum, what it means that you are doing this way, okay? You count this guy, rectangle, right? And then you count over here, right?
Yes.
Yes. And then you count over here, and then you do this over here, right?
Yeah.
If you do the left Riemann sum, you are basically using the rectangular, which you overestimate by this. You see? This is a thing that you do more than your real area is, correct?
Yes.
So that's called the overestimation because you add those extra. So that's the biggest value. You see here, right?
Oh, yeah.
If you use the right one, which is from the other side, if you do the right one, you do this way. If you use this guy over here, this guy over here, this guy over here, this guy over here. You see here, if you use this guy to estimate, then you underestimate your real area by this amount, right?
Yeah.
Yes. So left one and right one don't really estimate accurate enough, right?
Yeah.
And the midpoint, then does that mean that your midpoint is exactly the same one? Still not exactly, but better, you see? Because you see here, when you choose this thing, you see here, you use this guy to estimate this, right?
Yeah.
This part you overestimate, this part you underestimate. So these two kind of like compensate to each other, yes?
Yeah.
Okay, so that means your midpoint gives you the best estimation. And the real area under the curve, we learned it by, let me show you, okay. The real area under the curve is calculated by this. From 1 to 3, 1 over x dx, that's the area. And we do learn that ln x derivative is 1 over x, yes?
Yes.
And this is equals to ln x. And then choose 3 and 1. All right. Interval is a inverse function for the derivative. Okay. Does that make sense to you?
I understand where you got the ln x. What's that next to it?
Next one is use ln 3 minus ln 1. Okay. Yes. Ln 3 minus ln 1. Ln 1 is 0. Ln 1 equals 0. Ln 3, let's calculate ln 3 is how much? Length 3, yeah, you see? Length 3 is 1.098, correct?
Yes.
1.098, 6099, right?
Yes.
Uh-huh. You see? That's why this guy is close to this one, correct?
Yes.
Yeah. This is the most closest. This is the closest result. The other one, the other two, either is overestimate or underestimate based on what you see over here, right?
Yeah.
This is called overestimation. This is called underestimation. Yeah. A midpoint is close, but still not the accurate one. The accurate one has to do this called anti-derivative or integral, okay?
Okay.
So this is the second example. Let's see the third one. They show you the curve. Now this time they don't give you a function, it's show you a curve from 1 to 6. They ask you to use a 5 interval. Do the left Riemann sum. Oh, this is easy. So we can choose a point from the left, right?
Yeah.
So we are going to choose left. This is first point, second point, third point, fourth point, fifth point. Now we can do the subinterval. This one is so good. It's all one. Yeah, we just use the height plus it. That's it, right?
Yes.
Okay, so the left sum. This guy is 2. So first one is 2 plus 3 plus 4 plus 3 plus 2 times 1. I can just leave at it. Make sense?
Yeah.
Okay. Now, if I want to do the right sum is going to do from here, this guy, this guy, this guy, this guy, and this guy, right?
Yeah.
Okay, so I'm going to do, so I copy down 3 plus 4 plus 3 plus 2 plus 1, okay?
Mhm.
That makes sense?
Yes.
Okay, now I want to do the midpoint one. Midpoint, I'm going to choose this guy, this guy, this guy, this guy, and this guy, okay?
Okay.
So the first midpoint is, we do this midpoint. This is 2 and 3, so this is a 5 over 2. Next one, 3 and 4, so that's 7 over 2, right?
Oh, yes.
Next one is also 7 over 2. And next one is also 5 over 2, right?
Yes.
Last point is 3 over 2. Okay?
Okay.
Then we plus all of them together. Does this make sense now?
Yeah.
Okay. Now let's see. Let me move this one. Okay. So the oil is leaking. The rate of the flow is measured every 2 hours for a 12-hour period, and the data is listed. The assets draw a positive graph. Yeah, so that's easy. We just basically based on the value and then draw roughly the graph. Okay.
Okay.
This is nothing special. This is just graphing it. So we roughly see around here as 40. Okay.
Mhm.
So the 40 looks is the highest point, right?
Yes.
And 40 is the highest point. And we can see if this is 40, then over here is 10, 20, 30. All right.
Mhm.
So the first at 0, and then we also mark the bottom one. 0, 2, 4, 6, 8, 10, and 12. Okay. At 0, it is 40. At 2, it is 38. Okay.
Mhm.
At 4 is 36. At 6, it's 30. And at 8 is 26. At 10 is 18. At 12, it's 8. Yeah, okay. Yeah, I think my hand drawing is pretty good, right?
Yeah, it's really good.
Okay, so that's it. That's the graph. If you want to connect it, you can connect it. All right. Estimate the number of gallons of oil that leaked out of the tank during the 12-hour period by using a left Riemann sum with 3 equal subintervals. So they want us to do 3 equal subintervals. That means we have to split this into 3 equal pieces, right?
Yeah.
Okay, so we are going to do something like that. And left sum, oops. So we do here. All right, left sum. So let's find out this guy. Yeah, that's 40. Yes.
Mhm.
Then we plus at 4, that's 36. At 8, it's 26. Correct?
Yes.
And we use this times 4. Yeah.
Yeah.
Each subinterval is 4. Okay, that's it. So the previous one is finding the Riemann sum by looking at the function or looking by the graph. And this is called looking by using the table or using the data. Okay.
Okay.
So this C by finding a right Riemann sum with 3 equal subintervals. So we do from the right. So we do for the 4, it's 36. For the 8, it is 26. For the 12, it is 8. And then we times 4. Correct?
Yes.
Good. Now, next one. Estimate the number of gallons using midpoint, and with 3 equal subintervals. Well, the midpoint is easy because the midpoint is already given, right?
Yeah.
Yeah. This guy is the midpoint. This guy is midpoint. This guy is midpoint, right?
Yes.
Okay, so this one is even more easier because the data is already given. At 2, that's 38. At 6, that's 30. At 10, that's 18. Subinterval is 4. Good?
Yeah.
Now, wow, it's those table again. Let me move this one down. All right. So this time, all is being pumped into a tank and contains 120 gallons of oil. The rate at which oil is flowing into the tank is modeled by a R function, okay? And the R function is selected and listed in this table. So estimate in 12 hours using a left Riemann sum with 4 subintervals. Yeah, with 4 subintervals. So 4 subinterval, this is 1, 2, 3, 4. Well, they already give us, yeah, they already give us these 4 subintervals, right?
Yes.
Okay, so using a left Riemann sum. Now this time, be careful because this interval and this interval are not the same. So we cannot just do this plus this plus this and then times the 3. We have to use this guy times 3, right? Yes.
Yeah.
So watch out. Nobody claims that you have to always make it equal. Sometimes it could be unequal. Okay.
Okay.
So this is places you have to watch out. Left Riemann sum. So it's 8.9 times 3. Yes.
Yes.
Yeah, from the left. Okay. And then you do 6.8 times 2, right? Yeah.
Yeah.
Next is 2. Then you plus 6.4 times 4. Yes. And then you plus 5.9 times 3. All right.
Okay.
Does this make sense?
Yes.
Okay. For the B, it's asking for the right Riemann sum. For the right Riemann sum. So we are going to from using this guy from the right. So 5.7 times 3. Yes?
Yeah.
Okay. And next one is 5.9 times 4. Yes?
Yeah.
And next one, you use 6.4 times 2. Okay? And last one is using this guy times 3. Okay?
Okay.
Yeah, in this way, you won't mess up. Okay?
Okay.
Yeah. Everything is about being organized. You organize your notes, your work. It's easy to make it correct. Now that's it. Okay, that's it. So actually it's not hard at all. Next question. The coffee is taken into classroom and it's going to cooling down, okay? The temperature is 113. The rate, so here is a rate. The rate at which the temperature of coffee is dropping is modeled by this, okay? So all this is going down, all right?
Okay.
And well, the R is showing over here. So they want us to estimate the temperature of coffee at T equals 8 minutes by using a Riemann sum using 3 subintervals. Again, this is not guaranteed equal subinterval, so we have to watch out. 3 subintervals. So let's calculate the amount of temperature drop from the left, okay?
Okay.
The height is 5.5, yeah?
Yes.
Yeah, 5.5. You drop from your left, okay? So you use 5.5 times 3, yes?
Yes.
And 2.7 times 3, okay? and then 1.6, 2.7 times 2. Here is a typo. Correct?
Yes.
That's 2, okay. And 1.6 times 3. All right.
Uh-huh.
This is amount of temperature drop down. Yeah.
Yes.
And then you use, so this equals how much? We can calculate it by mental mass. Right?
Yes.
So 5.4 plus 4.8 is 10.2. So this equals to 26.7, right?
Yes.
Okay. And you're starting from 113. 113 minus 26.7. Yeah.
Mhm.
So estimatedly it's going to be 86.3. Okay.
Okay.
That's it. Fahrenheit. That's temperature after 8 minutes. And let's see the next one. Estimate the temperature at T equals 8 by using a right Riemann sum with the 3 subintervals. Yeah. So again, it's from the right. So we do from the right. We are going to, here is the way I write down this one and then I do this, okay?
Okay.
In this way, I'm going to reduce my careless mistake. Plus 1.6 times 2 plus 2.7 times 3, okay? Okay.
Okay.
All right, 13.3. So 113 minus 13.7. All right, that's my answer. Okay.
Okay.
Fahrenheit. Yep. Make sure also put the units for this kind of question. Okay. Teacher take off points without units. The last one. This one is fly with positive velocity. V is a differentiable function of t. V is showing in this table. Now use a midpoint Riemann sum with 4 subintervals of equal length. So 4 subintervals, that means we do 10 as each subinterval, right?
Yes.
Yeah, so you can mark this kind of thing. And then who is the midpoint? We can easily figure out the midpoint value, right?
Yeah.
Okay, that's the midpoint value. And the subinterval is 10. So let's see. We are going to, we can do this guy. We can say we use 9.2, yes?
Yes.
Times 10, okay? Plus 7.0 times 10. Plus 2.4 times 10 plus 4.3 times 10, right?
Yes.
Okay. So 92 plus 70 plus 24 plus 43, okay?
Mhm.
All right. So this is the total distance flight during the 40 minutes,
Okay.
correct?
Yes.
That's it? Okay.
That's it.
Well, let me check. I think there's answer key. Yeah, 229. Yay, good. I want to train your mental math for this part of calculation, because in this part, you are going to, if you take the AP calculus test next year, there is non-calculus session, which you need to do it by your mental math, okay?
I mean, from what you've heard, do you think the BC exam is hard?
Oh, actually, this year is the easiest one because they do the online test. That's the first AP test online in the history. But usually AP test is not so that easy.
You're still doing it online this year?
Next year, based on the coronavirus. Yeah, well, you see my mental math number gives all the correct answer.
Yeah.
Yeah, good, all right. So this is about the Riemann sum and, okay, oh, hold on. Some more things. So here, your school won't require you to do this one by doing the integral way or doing the derivative way. So far you just estimate the area under, okay? You see here, you have the integral from 1 to 6 for constant of 4. So you draw here as a constant 4. That's 4. From 1 to 6, then you are asking for the rectangular area under. This is 5. This is 4. This rectangular area is 4 by 5. That's 20. Does that make sense?
Yeah, I think.
Okay. And the next one, you draw a line of x plus 2, y equals x plus 2. And then you are looking for 1, 2, 3. So you are looking for the trapezoid area from here to here. Okay.
So the numbers on the left are just the x values?
Yes. This guy is just your x value. This is your lower limit. This is your upper limit. Okay. You are looking for the area under this line from 1 to 3 for your x.
Okay.
That makes sense?
Yeah.
Okay. Now, you can get the area by this way. Next one, for the C. When you see this one, you kind of feel scared, but look, if you do this, if you do y equals to square root 4 minus x squared, this is saying y squared equals to 4 minus x squared. This is also saying x squared plus y squared equals to 4. So you are looking for a circle, and your radius is 2, right? But here, because this only took the positive part, so it's a positive half circle in orbit. We learned this, right?
Yeah.
So this means you are looking for the area of this half circle. Your radius is 2. The half circle area is 1/2 times pi times 2 squared, which is 2 pi. Okay?
Okay.
Yeah. I will give you all the notes, okay?
Okay.
And the other one is saying this function as showing this. Yeah, they ask you what's the integral from -4 to +4. So look, if your line is under the x-axis, this area is negative. If the area is above the x-axis, it's positive, okay?
Okay.
Yeah, so you calculate this triangle area, you see here? For this rectangle, this is 1, 2, 3, this is 1, 2. So this area is 3, yes?
Yes.
Because 2 behind 3 divided by 2, so this is 3. And -3, right?
Yeah.
Correct? And then you can calculate it here. That's 3 divided by 2, 3/2. This guy is 6. A half is 3. This guy is 2, right?
Yes.
Divided by 2, 1. Negative. That's it.
Oh, okay.
Yeah, I believe after today, you learn this, tomorrow's stuff is going to be easy for you. That's why for those hard AP class, especially like AP Physics, AP Chemistry, AP Calculus, you will have to learn it in advance. Yeah.
So dx is just asking for the area under the curve.
You see here, okay? You treat this integral as this way. You treat this guy as a sigma. This guy is sigma. Yes?
Yes.
X plus 2 is your y value. Is your function. Dx is doing the delta x. Right?
Mm-hmm.
That makes sense?
Okay. Yeah.
So this is doing the summation. When you when you make this into infinite many rectangle, okay? Which is exactly value of the curve under the curve from this lower limit to this upper limit. That's it. Okay.
Okay.
Yeah. Does this make sense now?
Yeah.
You see, hey, this is the integral. This is integral, which is a summation. Okay. This is your function, your y value. That's your delta x. When you write down this subinterval value together, it's going to be the exactly area under from this lower limit to this upper limit. Okay.
Okay.
Yeah.
This reminds me a lot of physics.
Yes. If your lower limit and upper limit are the same, it's the same line. Yeah.
Mm-hmm.
Don't bother to solve it. Come on, this is 0. Okay.
Okay.
If your A and B switched, come on, you just make it to be negative. Okay.
Okay.
If you times a constant, come on, you take it out. Okay.
Okay.
If you have A to B, if you have a midpoint between, doesn't matter midpoint or not. If it's a C between A and B, you can do A to C first, then C to B. Okay.
Okay.
Well, that's all. Let me give you all these 2 notes. Okay. I think this is very good notes for what you learn right now.
Yeah.
You see, after you prepare it, you feel better, way more better for your test. It's really worth learning hard for this class. Okay. Yeah, you already improved so much. Imagine, you're like now the top students, especially the top of the girls who learn this kind of level class.
Yeah, my entire class is all guys for some reason.
Really? Yeah, well, you can do better than them. All right, that's all. Okay.
Okay, thank you. Bye.
Okay, thank you. Bye.